Okay, so we've got another example to a particle being projected. So in this case, it's projected from point O with speed 35 meters per second and an angle of elevation 30 degrees. The particle moves freely under gravity. We're going to find the length of the time for which the particle is 15 meters or more above O. Okay, so a couple of things to sketch. So first of all, the velocity itself, the initial velocity that is, 35 meters per second, angle of 30 degrees. So we need to break it into components. So the vertical component will be 35 sine 30, which is equal to 35 over 2. Horizontal component is 35 cos 30, which is 35 root 3 over 2. And then quick sketch of what's going on here. So we've got particle projected like so. Then if we draw a line here to represent 15 meters, we want to find the time from this point to this point. What we really want to do is work out the time at which it's at 15 meters, and then we can just subtract to find the time that's above 15 meters. Okay, so to do that, we want to consider the vertical motion. So initially, the vertical velocity uy is 35 over 2. The acceleration is always minus 9.8 meters per second squared with projectiles. The displacement we're talking about is 15 meters up, and we want to find what t is. Okay, so that's going to involve using s equals ut add a half a t squared. So we can substitute things into this. So we're going to get 15 is equal to 35 over 2t minus 4.9, half of 9.8 is 4.9, t squared. It's really a quadratic equation, so let's rearrange to make 4.9 t squared minus 35 over 2 is 17.5 t, add 15 equals 0. I just want to use any method to solve that, so I'm just going to use the calculator function. Okay, so doing that, I get two solutions. I get t equals 2.1429, or the other one is 1.4286. So those are the times at which it's at 15 meters. So it's above 15 meters between those two times. So this one's the 1.4286. This is the 2.1429. So the answer to the actual question is then 2.1429 subtract 1.4286. Okay, and that comes to 0.714 seconds to 3SF.